Welcome to Biotechnology. This presentation will discuss about analysis of multiple strategies in upstream and downstream processing of lactic acid by Saccharomyces cerevisiae and Rhizopus oryzae. With this review paper, our aim is to provide information on multiple upstream and downstream processing strategies that have been done in lactic acid production by yeast Saccharomyces cerevisiae and fungi Rhizopus oryzae. Before we jump to the upstream and downstream, let's look at the byproduct. Several types of microorganisms are capable to produce lactic acid. There are two forms of lactic acid, which are D-lactic acid and L-lactic acid. And currently, high demand of L-lactic acid are observed in many industries. Lactic acid bioproduct can be classified into four grades based on the purity. First is technical grade with 20 until 50% purity, and the example is detergent. Food grade with 80% purity, and this can be found as preservative. Third, plastic grade such as food container. And lastly, medical grade with 90% purity, and the example is surgical sutures. This is the flow chart of what we will be covering for the rest of the presentation. We start with fermentation as the upstream processing, continue with separation and purification, which is the downstream process, and finish with the packaging of lactic acid.
Crucial step in lactic acid upstream process is fermentation. Microorganisms used are yeast, specifically Rhizopus oryzae and Saccharomyces cerevisiae, both yeast able to produce optically pure L-lactic acids. As for the substrate used for energy source, pure sugar are often expensive, therefore we provide cheaper alternatives such as starch, lignocellulosic biomass, molasses, and dairy waste. To achieve optimum production, regulating fermentation parameters are important. As for the fermentation mode, lactic acid can be produced in batch, fed batch, also continuous fermentations. Second is temperature and pH settings. Saccharomyces is found to have optimum pH of 3.5, while Rhizopus oryzae produce optimum lactic acid in basic pH. Both have similar optimum temperature. Lastly, aeration and agitation rate, where both yeast requires different optimum agitation and aeration rate.
Now moving on to the separation and purification method. First is the conventional method, which is precipitation that is easy to operate, fast, and quite effective. However, it is not capable for producing high purity lactic acid. The second one is membrane technologies. These methods are capable of producing high lactic acid quality, however still has issue with membrane fouling. It also costly and produces high amount of wastewater. The third one is the solvent extraction. This method is capable of producing high yield of lactic acid with high efficiency while being cost and energy effective as well. However, the system is still quite hard to be upscaled. The fourth one is the reactive distillation, which is capable of producing lactic acid of high level purity. However, it requires high installation cost and requires lots of energy to operate. The fifth one is crystallization, which is able to yield a stable lactic acid free from colored impurities. However, this method is not suitable for heat-sensitive materials and thus only suitable for producing plastic-grade lactic acid.
The final product of lactic acid can be liquid and powder form. The advantage of liquid form is prolonged product shelf life. However, it is corrosive and can induce irritation. Moreover, in the food industry, liquid lactic acid can only be added to the dough, while for powder, it can be mixed directly with powder mixes. However, the disadvantage of powder form is easy to disperse and can cause irritation. The packaging for liquid form can be glass or plastic bottle, while powder form is packaged in plastic or polypropylene bags. Standard upstream or downstream method cannot be determined because first, all variables in upstream processing including microorganism, substrate, fermentation mode, and parameters are all important to maximize the fermentation result. Next, each method in downstream processing has its own advantage and disadvantage. Therefore, the compatibility of various methods will be vary depending on the circumstances and the cost. As for future studies, it can be done with the purpose of updating the outdated information or seeking novel knowledge related to lactic acid production, specifically on downstream processing. That's all from us. Thank you.